Okay, today we're going to talk about laws of logarithms and change of base formula. So, laws of logarithms are very similar to laws of exponential, laws of exponents. So we're going to go through a few laws, we're going to practice a few examples, and then y'all are going to do a worksheet over it to practice. So the first law we're going to learn is whenever you are multiplying two terms in a log. So you'll see it in that box on your notes. Number 1, log base of b of m times n. They're right next to each other. It means you're multiplying. So whenever you're multiplying, if you want to expand it, because this is really condensed, if you want to expand it, multiplying with logs, whenever you're multiplying, you want to add them. So log base of b of m plus log base of b of n. So you see how now it's expanded? We went from multiplying to adding. Okay, and it works the same way, like going backwards. Let's say you want to simplify an expression or an equation. If it's adding and you want to condense it, you would be multiplying. So it's really similar to laws of exponents, where if you're multiplying the same base, you add the exponents. So it's really similar. Number 2, second law, if you're dividing and you want to expand this, you're going to be subtracting, just like laws of exponents. You take the numerator minus the denominator. Okay, and like I said before, if you want to go backwards, if you want to condense it or simplify it, and you're subtracting, to condense it, you would divide. Alright, and last law on that page, log base of b of m to the k power. What happens is that exponent goes in front of the log and you end up multiplying. So it's like laws of exponents, where if you have a power to the power, you multiply. It's kind of similar to that. But that exponent, that k, will go in front of the log. Okay, so today we're going to do some problems where we expand the logarithm, and then we'll do some problems where we condense it or simplify it. Okay, so let's look at our first example. Number 1, we have log base of 10 of 5ab. And what we want to do is expand these expressions. So they're going to start out pretty condensed, and we're going to expand it using the laws we just learned. So on number 1, log base of 10 of 5ab. So, like I said, if you have a number or a letter and they're right next to each other, it means you're multiplying. So here we're multiplying. If you want to expand it, look at your laws at the top in that box. If you want to expand that, you're going to be adding. So it's going to be log base of 10 of 5. We're going to put log base of 10 with each number and each letter. Okay, so log base of 10 of 5 plus log base of 10 of A plus log base of 10 of B. Okay, so we just expanded that logarithm. And that's all we're going to do right now. We're not going to solve any logarithms today. We're still not ready for that. We're still laying that foundation, learning the laws and how logarithms work. Okay, so let's try number 2. Number 2 has a couple of different laws in this problem. So let's see, we have log base of 5 of 8x cubed. Okay, so we have 8x cubed and they're multiplied together, right? So if we want to expand that, it's going to be log base of 5 of 8 plus log base of 5 of x cubed, right? If I want to expand them a problem where I'm multiplying, I'm going to add them. Now, it's still not expanded as much as it possibly can because we have an exponent here. So we can keep expanding it. That exponent, if you remember that third law we went over, the exponent's going to go in front. So our final answer is going to be log base of 5 of 8 plus 3 log base of 5 of x. Okay, so you might use one law of logarithms. You might use all three. Okay, but if you're expanding, you shouldn't end up with an answer where there's anything multiplied in the log, like after the base is what I'm talking about. Anything divided in the log, or any exponents. If you end up with that, you're just not finished yet. You haven't finished the problem. Okay, and that's if you're expanding. So next one, number 3. Okay, so you know how I said yesterday how rational exponents are coming back? They're back. Okay, number 3, we have log base of 10 to, let's see, of a to the 5th divided by the square root of b cubed. Okay, so we're dividing. If we want to expand it, we're going to be subtracting those two. So log base of 10. And if you remember from yesterday, a log base of 10, you don't have to put base 10. It's kind of an understood 10. So if you don't want to write the 10, you don't have to. It could just be log of a to the 5th power minus log of the square root of b cubed. Okay. If you want to put a base of 10, that's fine with me, but you don't have to. Now, and I would take this one step at a time. So we went from dividing to subtracting. Okay, that's good. Now we have exponents here. We have a to the 5th power that we need to expand. And then over here with our b, this is the same thing as b to the 3/2 power. You have to remember your rational exponents that we went over before. Okay. Things that we've learned at the beginning of the year, things that you've learned in Algebra 1, you're going to have to keep working on that. We use all of that stuff. It builds and it builds to help us with other concepts. So it doesn't go away. Now, the reason it's 3/2, and I can't go through all of rational exponents right now, but I'll do a quick review. Rational exponents, your power goes on top, and then whatever root it is will go in the denominator. So on this one, if it doesn't have a root outside that radical, it's an understood 2. So that's why it's b to the 3/2 power. Okay. So we have another exponent that we need to expand. So our final answer would be 5 log of a minus 3/2, our exponent goes in the front, log of b. Okay. Okay, so I want y'all to try number 4. I'm going to give you 30 seconds to try number 4 and then we'll check. Okay, so if we want to expand this one, we're multiplying 6 squared times x squared times y cubed. So if we want to expand it, we are going to add them. So log base of 2 of 6 squared plus log base of 2 of x squared plus log base of 3, or sorry, same base, log base of 2 of y cubed. Okay, and you're not finished yet because we have exponents. So our exponent will go in front. So your final answer is 2 log base of 2 of 6 plus 2 log base of 2 of x plus 3 log base of 2 of y. So your exponent just goes in front. Okay, on the next section we're going to condense. We're going to go backwards. Okay, so let's look at number 5. On number 5 we have log base of 5 of 7 plus 3 log base of 5 of x. Okay, what I like to do first is if I have a number in front of a log, I go ahead and condense that first. So like I said, we're going backwards. So if I have a number in front of the log and I want to change it, that's going to be my exponent. Okay, we're working backwards. Now, if I'm adding these two and I want to simplify it, the way to simplify this is to multiply them. This is your first law that you learned. So log base of 5 of 7x cubed is your final answer. And you can double check yourself. You can work, like, I got my answer to be log base of 5, 7x cubed. If I want to check it, I'm going to expand it. So it'd be 7 plus x cubed, the 3 would go in front, and you should end up back where you started. Okay, so you can check yourself. Okay. Let's try number 6. Okay, on number 6, we have 3 log base of 6 of m minus, let's see, minus log base of 6 of n over 2. Okay, now the thing about this one is it's not saying log base of 6 of n over 2. Okay, do you see the difference between those two? On the second term here, what's happening is you actually have a 1/2 in front of that log. Okay, these two terms are completely different. So don't get that mixed up. Okay, so we have 3 log base of 6 of m minus 1/2 log base of 6 of n. Now, one thing to remember too, whenever you condense, just like laws of exponents, they have to have the same base. So like these both are a log base of 6, they're the same. That's why we can condense them. If they had a different base, then it won't work. So, just a little FYI. So like I said before, I go ahead and fix my exponents. If there's a number in front of the log, I go ahead and change that. Okay, so this would be m cubed now. When I condense it, this would be n to the 1/2 power. Okay, so now that I fix my exponents, I'm subtracting. So if I want to condense it, I'm going to be dividing. This is our second law, if you want to look back at the front page. So log base of 6 of m cubed, remember we changed that, divided by n to the 1/2 power. Alright, now see how we have a rational exponent I want you to go ahead and fix that and